In this study, my colleagues and I were interested in the contribution of visual information to tactile roughness discrimination of course services. In the top right corner, you see our Murdoch setup, which we use to superimpose the visual stimuli on square wave gratings. The participants pressed two gratings using their right index finger and decided which was rougher. Throughout the experiments, young adults were tested discriminated the roughness of the same pair of tactile stimuli. This pair of gratings had a 40 microns difference, producing about 75% correct performance in pilot testing. In baseline conditions shown on the left side of the bar graph, roughness was judged with the eyes closed or open. In eyes open conditions, the visual details about a grating spatial period were vertical or occluded by a blurring plastic filter. In the congruency conditions on the right of the bar graph, the relationship between visual and tactile spatial information was manipulated. One of the two tactile stimuli was paired with a mismatching visual gratings that was either significantly coarser or finer. Trials where the mismatching visual tactile signals were both fine or both coarse were labeled congruent. When the mismatching modality signal opposing relative roughness, for example, the coarser tactile grating paired with the much smoother visual grating, the trials were considered incongruent. The different conditions were randomly interleaved. Bias-free measures of sensitivity D' are shown by the gray bars in the bar graph. Roughness discrimination was improved in baseline conditions with the addition of both spatially informative and non-informative visual inputs relative to the no vision baseline. There was no significant difference between the two visual conditions. From the correlation graphs, we see that the visual benefits participants obtained from non-informative vision was negatively correlated with their tactile sensitivity. When we examine the data split into low and high sensitivity group using median, we found the benefits of the visual information were only evident for low sensitivity participants. These effects are shown by the solid and dashed bars. Similar analysis of the congruency data show opposing effects for the low and high sensitivity participants. Incongruent pairings impaired discrimination in the high tactile sensitivity group, but improved the performance of the low tactile sensitivity participants. Our data suggests that responses to visual information in a tactile roughness discrimination depends on the tactile sensitivity. Our findings suggest that participants with good tactile sensitivity are not able to ignore discrepant visual information, whereas poor tactile sensitivity participants experience contrast effect, which improve their tactile discrimination judgments.